Welcome back to Precalculus, folks. Today we're in Chapter 1, Section 3, talking about absolute value. And by definition, the absolute value of a number x is its distance from 0 on a number line. On a number line, regardless of direction. Okay, so if we talk about like, hey, the absolute value of x is equal to 3. Okay, well, if we have a number line and there's 0, there's 2 points that are 3 units away from 0. Obviously over here at 3 and over here at -3 as well. Okay, so that's why the absolute value of x is equal to 3 at -3 and 3, because its distance away from 0 is 3 units regardless of direction. So if you really want to understand absolute value, understand that it is the distance from 0 on a number line regardless of direction. Okay, so here we go. We're going to do a quick example here, and you're going to see why you see multiple answers as we went through Algebra 2 and everything. So simple properties of equality. So let's go ahead and subtract 4 and divide by -2. So we're going to end up with the absolute value of 2x minus 1. We subtract 4, we get -2. Divide by -2, you get 1. Okay, so that means that 2x minus 1 is exactly 1 unit away from 0 on a number line. So let's just go ahead and draw that really quick. So if there's 0, over here is 1, that's 1 unit. Over here is -1, right here and here. So that means that 2x minus 1 has to either be equal to -1 or 2x minus 1 has to be equal to 1. So that's where we're going to get our two equations that we have to solve to find x. Okay, so here we go. 2x equals 0, so x equals 0. Okay, over here, add 1, so we get 2x equals 2, x equals 1. So there's your two answers. Because 2x minus 1, the absolute value of 2x minus 1 is equal to 1, therefore 2x minus 1 could either be at -1 or 2x minus 1 could be at 1. Okay, the multiplicative property of absolute value is a thing, and you can understand it if you choose to, but nothing really changes from what we just talked about above. Okay, so we can just keep doing our property of equality. Subtract 1, you get 6. Divide by 3, you get the absolute value of -4x is equal to 2. Okay, so all that means is that the distance that -4x is away from 0 is 2. So there's 0, there's 2, there's -2, you can put some dots, whatever. But -4x is either at -2 or -4x is at 2. So that's how we're getting our two equations to solve. Now we divide by -4, you get x is equal to 1/2 is one of your answers. And if you divide by -4, you get x is equal to -1/2 as your second answer. Okay, moving on. Now let's talk about how absolute value and inequalities relate. Okay, absolute value is still its distance away from 0 on a number line regardless of direction. Okay, now we're going to have an inequality here. So let's go ahead and just use the property of equality, isolate the absolute value by itself. So we're going to add 1, we'll get 5. Divide by 5, we'll get 1. So we're going to end up with the absolute value of 3x minus 2 is less than 1. Okay, so that means that if we draw a quick number line, here's 0, and here's 1, and here's -1, that the distance that this thing is away from 0 is less than 1, which means it could be anywhere in here where I'm shading, or it could be anywhere in here where I'm shading. Now notice it's less than, not less than or equal to, so we're going to have an open dot. We don't want to be on -1 or 1. So we know that our 3x minus 2, okay, has to be somewhere in here between -1 and 1. So we can say 3x minus 2 is less than 1, greater than -1. And now it becomes a really simple solve. Let's go ahead and add 2 to both sides. So we're going to get a 1 here and a 3 there. And let's go ahead and divide by 3. So you're going to get a 1/3. I'm writing a little smaller, but we're going to get a 1. And so our answer is all solutions from 1/3 to 1, not inclusive. We're putting it in interval notation there. Okay. The way I like to remember this is the absolute value is less than 1. This is an intersection right here that we shaded. So I like to write this out as less than. It is an and statement. It is an intersection. It is an and statement. Okay, we know we're going to be shading in between 2 values. Okay, and solving from there. Okay, so now let's go ahead and talk about what happens when it's a greater than statement. Okay, nothing changes in our process. We're still going to use property of equality. We're going to add 2, we get 9, divide 3. So we're going to end up with the absolute value of x plus 4 is greater than 3. Okay, so that means that the distance that this is away from 0 is always bigger than 3. So draw a quick number line. There's 0. Put 3 right there and negative 3. So the distance that x plus 4 is away from 0 has got to be bigger than 3. So first of all, let's put some open dots because we don't want to be equal to. And the distance away from 0 is greater than 3. So that means we're going to be shading out here. And we're going to be shading this way. Because all of these values have distances away from 0 that are greater than 3. So now let's just go ahead and set up our solve. So x plus 4 for this piece has to be less than negative 3, or x plus 4 has to be greater than 3. And now it becomes a real simple solve. Let's subtract 4, so we get x is less than negative 7, or x is greater than negative 1. So in our interval notation, less than 7 means negative infinity to negative 7, or means union, and greater than negative 1 means negative 1 to infinity. So there's our answer in interval notation. Okay, what I'd like you guys to do now is to pause your video and do the next 4 examples on your own. Just want to draw a quick some tips for you. Notice we have an equality, so it's like our first example we did. And then in the next 2, you're going to notice that we're dividing by negative numbers. So remember, when you divide by negative numbers, you're going to have to flip your inequality. Okay, so try these 4, and we can answer questions on them in class. Okay, but let's talk a little bit about this last example here right now. So a vending machine that fills beverages into paper cups is programmed to fill each cup within a certain tolerance. Okay, if the cup is overfilled, the company loses money. If it's underfilled, it's unsuitable for sale. So suppose that these cups are 24 ounces, and they must be filled within 2 ounces. We want to write this relationship as an absolute value inequality, and then solve the inequality, and we can talk about what it means. Okay, so if the tolerance is 2, means whatever we fill it to minus 24 has got to be less than or equal to 2. Okay, so absolute value of x, just because saying x is what we fill it to, minus 24 has to be less than, since tolerance can be 2, we can be on 2, it can be less than or equal to 2. So let's see if that makes sense as we go through and solve. So we notice that it's a less than statement. It's a less than statement. Okay, so we know that, let's draw it on a number line. There's 0, here's 2, there's negative 2. Okay, this, whatever is poured, has to be somewhere in here. It has to have a tolerance that is less than or equal to 2. Okay, it has to have a distance away from 0 that is less than or equal to 2. So if we put in like 1 ounce too many, we're good. we put in 1 ounce too less, we're good. But if you put in 5 ounces too many, okay, you can see that that's not in our solution. Or 5 ounces too little, obviously that's unsuitable for sale and not in our solution as well. So let's go ahead and solve. I'm going to go over here and say x minus 24 has to be bigger than or equal to negative 2 or less than or equal to 2. It's got to be smashed between negative 2 and 2. Okay, so if we add 24 to each side, we get 22 less than or equal to x less than or equal to 26. And this answer should make some sense. Because if the cups are 24 ounces and we have a tolerance of 2 ounces, we're allowed to fill it up to 26 or down to 22 or anything in between. But once we leave that range, that's outside of our tolerance and considered unsuitable for sale, or the company is losing money. All right, well, if you guys have any questions, let me know. Make sure you've done those examples above, and I'll see you guys in class to answer questions. Have a good day.